Good morning, everybody. We are going to be looking at our angles, measurement, and classifications. This is what the packet actually has on there, but it is called just the angle addition postulate. So just a couple of things that I want to review and go over with you. An angle. So this is an object formed by two rays, and they have a common endpoint. That's what an actual angle is. The name the sides of the actual angle. So we have to name these as our rays. Remember, this is your ray definition, that arrow. They always go to the right. And we are going to name it from the endpoint to the other endpoint. And then our other ray is also from A to C with that arrow on top as well. Now we're going to name the vertex of this common endpoint. So the vertex, remember again, this common endpoint that both of those rays actually share is point A. And then we're going to name the angle, but we're going to name it three different ways. So just how I said angle A, that can be our first angle direction that we are talking about. There's only one angle here, so we are allowed to name it that. Then we have our angle. This represents an angle, by the way. Remember, this letter A always has to be in the center, however direction we actually go. So if I start from B, A, C, remember that A is in the middle because that is the angle we are discussing. And then the last way we can actually do this would be from the bottom to the top. So CAB, angle CAB would be the other name for this angle. As long as our A is in the middle, we are okay saying this. We are only allowed to use angle A here because there's only one given angle. If we had a segment bisector here, or an angle bisector, then that would actually cut this into two different angles. We would not be able to say angle A there unless we were talking about the entire angle. We will have more practice with this, you guys, anyways. So now we have our different classifications of our angles. So remember, this was our acute angle. This was our measures between 0 to 90 degrees. And then this is our acute angle. This should be the angle symbol. So a right angle, obtuse angle, and straight angle. So that's what those symbols should be. And so this one is from 0 to 90 degrees. So let's actually label which one is actually acute. And actually our letter A is acute. So this is smaller than 90 degrees and between 0 and 90. Our next one, our right angle, measures is exactly 90 degrees. We can see in our example here, this is the 90-degree angle that represents that. So this is our right angle. Then we have our obtuse, measures between 90 and 180, so it has to be larger than this, but it can't be a straight line. So this is our obtuse angle. And then our straight line angle, which measures actually to 180 degrees exactly. If you think that when you were standing here and you were to either turn around, that's 180 degrees, but this is our straight line. Or if you're doing a 180 on a snowboard, you just turn around basically. Okay, so I think I erased this on your copy here. So our angle addition postulate, this is something new that for you guys. So we have our measure of our angle ADB. So ADB is here, angle ADB, and we kind of already went over this as well. That is going to be with my other angle that I have, and my other angle is the measure BDC. So this angle plus this angle will actually equal the entire thing. So the entire thing, hopefully you guys have a different color. I only have black, so this entire thing, if I add those two, it should equal the entire angle. Okay, so I could draw this a little bit smaller. So if I have just drawing this angle, we're going to add it to our other angle, that BDC. So that angle is a little bit bigger. And then that should equal our entire one. So all the way from A to D to C. So that's each of our little chunks. I just drew it as an image there. Okay, so let's actually start calculating and using this algebraically. So if the measure of angle LYN, so here we have LYN, is that entire angle, is equal to 125. So this entire thing is equal to 125 degrees. What are the measures of LYM? So this angle here first. And then what is the measure of MYN? Remember, this is how I know which angle it's talking about, MYN. They want to know what each of those angles actually represent. So let's go ahead and use our angle addition postulate. So if I set this up, I have 4p plus 7 plus 2p minus 2 equals 125. So angle plus our angle equals the entire angle. So now I'm going to go ahead and combine my like terms. These 4p and 2p, I have 6p. 7 minus 2 is a positive 5 equals 125. I'm going to go ahead and subtract 5 from both sides. I end up getting 126p. And now I'm going to go ahead and divide by 6 as my last step. And I end up getting p to equal 20. Okay, so once that p-value equals 20, just like our segment addition postulate, you guys, you're now going to plug in that value to see what each of these angles represent. So our measure of angle, let's do LYM first, was equal to 4p plus 7. So I do know what my p-value actually represents is 20 now. So now I'm going to plug that in for the p-value. 20 times 4, we get 80, plus 7, so I get 87 is the measure of angle LYM. Okay, so 87 degrees. Sorry, if I had a little degree symbol, you see the little degree symbol there, that's what that represents. So that was the measure of this angle just here. So this is 87 degrees in here, just this side of that angle. Now I'm going to determine the other one. So the measure of angle MYN, we're going to have to squeeze this in here, is equal to 2p minus 2. Okay, so I'm going to plug in the 20 for the p again. So I have 2 times 20 minus 2. So now I get 40 minus 2, and I get 38 degrees. That was the measure of angle MYN. Okay, so this right here is 38 degrees. I'm going to double check my math. I want to make sure that my two angles add up to that 125. So if I have 87 and then I add that to 38, let's double check that I get 125. So 87 plus 38 in my calculator, yay, it does equal 125. So check, I did do my math correct. These are the measure of each of those angles separately. Okay, now we have our angle CBD, which is right here. This is a straight line, a straight angle. So this is equal to what? 180 degrees. Now our measure of, so if you have the straight line right here, it's exactly 180 degrees. Now the measure of ABC is going to be 2x. So from here to here is 2x. The measure of ABD is 60 degrees. So this portion here is 60 degrees. Put a degree symbol on this. We're talking about angles. So we need to just write an equation and find the actual value for x. So when we find our equation here, we have, let's write this out. So if we have our one angle plus our other angle, that has to equal 180 degrees because it's a straight line. This whole thing is a straight line. So then now, so this is my equation. This is the first part of it that we needed to figure out. Now I'm going to go ahead and use that equation to solve for x. So for my value here, 2x plus 60 equals 180. We're going to subtract 60 first. 2x equals 120. Now we divide both sides by 2, and we get x equals 60 degrees. This problem just wanted us to solve for x, so make sure that you guys are reading the instructions here. So that one was just an x value problem. So we are done with this problem. Okay, these last two problems here, they want us to draw a diagram to help solve each problem. So let's go ahead and read it first before we draw our diagram. So x is the interior of LIN. Measure of LIN is equal to 100. Measure of LIX is 14a. And the measure of XIN is a plus 10. We're going to find the value of a and then the measure of both of those values there. Okay, so let's actually draw our angle of LIN first. So if we have, I'm going to draw it kind of bigger because I know we're going to be squeezing things in. So L, I, and N. X is the interior angle, so of LIN. So I need to draw an interior angle here, and this is X. Okay, so now I'm going to label each of these values. LIN, this whole thing is supposed to be 100. 100 degrees there. This is a 100, you guys, if you can't read that. And then I'm going to go on and start labeling these. LIX is 14a. That's just this portion of it. Then we have a plus 10 is just this portion because it's XIN. We're going to find the value of a, so we're going to have to solve for this using our segment addition postulate. And then once we find the measure of a, we need to plug it back in to actually determine each of those values. So we're going to go ahead and use our segment addition. So 14a plus 10, angle addition postulate. So this angle plus this angle has to equal the 100 degrees. Combine like terms. I have 15a plus 10 equals 100. Going to subtract 10 from both sides, so I get 15a equals 90. I'm going to take that 15a right up here. We're going to divide by 15 from both sides. Once I have 90 divided by 15, I end up getting 6. So a equals 6. Yay, I determined a. Check, I did that part. Now I need to plug it in for both of these equations to determine each of those angles. So let's do the measure of angle LIX first. That's the 14a. So measure of angle LIX is equal to 14 times 6. Measure of angle ILX is 84. Okay. Then our next one is the measure of XIN, of angle XIN, and that was a plus 10. So the measure of XIN, we get 6 plus 10, and therefore the measure of angle measure XIN is 16 degrees. So I'm going to double check that I just did this correctly, making sure that it equals to 100, which is that whole thing. So if I did 84 plus 16, yep, that equals 100 degrees. Check, I did my work right. All right, you guys, I want you to try number 2 on your own. So when I'm looking for the notes, I am looking that you attempted it. It's totally fine if you get it incorrect. I just want to see that you actually did it correct. Okay. So for those values there, go ahead and attempt them, and I will see you in class tomorrow.